Hello, Physics 40S. We have an example here of eddy currents that we'd like you to make note of. There's a few things that we're going to get you to write down. I'm going to start this pendulum swinging. You'll notice there's some neodymium magnets on the bottom, so very strong magnets just suspended. And I'm just going to start them swinging. Hey guys! And then Miss Thorne's going to come up. Just because, you know, like this is what happens all the time, right? All of us teachers, we really miss you, so we want to make sure we get to say hi.
Waiting for the clapping.
Okay, so we have this swinging magnet now. Thank you, Miss Thorne. It was nice to see you. As the magnet is swinging, you'll notice that nothing seems to be changing. It's just swinging normally. I have an aluminum sheet right here. Remember, aluminum is not magnetic. Yet, when I slide it underneath, something happens to stop that swinging pendulum. And it stops it dead in its tracks. You can see there is a little bit of, like it's not actually touching the aluminum sheet, so it is a little ways up above. Notice what happens when I remove the aluminum. Okay, I did not touch the pendulum, yet it started swinging on its own. Okay, let's see that pendulum action again. So we swing. That's kind of a bad swing I did, but that's okay. It seems to be wobbling a little bit, but okay. So as it's moving, the aluminum comes in underneath, no contact, yet the motion is stopped. Now, remember I called this eddy currents at the beginning. What's happening is this aluminum, which is an electrical conductor, but not a magnetic conductor, is experiencing a changing magnetic field. As the magnet swings across, the electrons inside the aluminum are experiencing a changing magnetic field, which means they're going to feel a force and an EMF. And inside the aluminum, they can move freely. So they're going to move. As those electrons move, they create their own magnetic field, and that magnetic field wants to oppose the change. So as this swings towards, it wants to slow it down. So it's going to try to push against it, slow it down. As it swings away, it's going to try to pull it back. So it keeps changing direction. So we get little tiny currents inside the aluminum, which we call eddy currents, because they may be little small circular currents. And those are going to change to stop the motion of that pendulum. Now, magnetic brakes would work in this way. We might use, because there's no contact, there's no friction. So magnetism can be an excellent option to stop movement without wear and tear on the materials. Have a great day.